All right, so let's walk together through this tutorial of using the Nx Standalone project setup to build a React application. So what are we going to learn? First of all, we're going to have a look at what that standalone project setup is all about. So it's basically a single project setup compared to the more traditional Nx monorepo setup. And it's very similar actually what the Create React app would provide you. So it's one project in a workspace to build a React application. Now we are going to have a look at the most common things you would want to do. So first of all, to set up the workspace, to run the workspace, serve your application, build and test it, we're going to have a look at what Nx provides you with that in the sense of built-in linting, running tests, running end-to-end tests with Cypress. We're also going to see how code scaffolding can help you generate new components or even entire libraries or projects in that workspace. And that said, we are going to see how we can use such local libraries, even in a non-monorepo workspace, to modularize your React application for better maintainability. So let's go. So to create a new workspace, I can use the create Nx workspace command, appending it by npx, such that I don't have to have a global installation here of the Nx CLI. And let's call this my React app. And I also know that we are going to create a React standalone. So I immediately pass that preset in. You might also want to append here latest in case you have already used the create Nx workspace command, such that you force npx to pull down the latest version of it. Now notice if you don't know the preset, you can just leave it away and Nx will guide you through various questions to actually arrive at the best setup that works for you or that is most suitable to your current use case. So once you choose the React standalone, you can see that the first question that we get asked is which bundler to use. And we have here Vite, Webpack, and RSpec. Now for this tutorial, I'm going with Vite. You can also choose different style sheet formats. I'm just going plain CSS as it's not really relevant for this tutorial. Now, another question that we get here is whether we want to enable distributed caching. Now, what Nx provides you locally is with a mechanism that caches your computation, meaning it avoids you running the same computation if it's not needed because it has already been run before. Now, this all happens locally on your machine, so basically within your node modules folder. But obviously, if you want to benefit from these speedups also on CI, you need to have a central place. And that's exactly where this opt-in leads you to, basically to use Nx Cloud, which then can distribute that cache across multiple machines. So once we open this up in VS Code or whatever editor you prefer, you can see it's very similar if you have been using Create React app in the past. It's very similar to that. So you see the single source folder at the root here, which hosts our React application. So we got some examples here generated where there's the main TSX file, which loads in some app component that has some example components inside that we can then run and expect in the browser. There's some more stuff, however, in this workspace. So we see the Vite config, which is because we chose Vite as our bundling mechanism. There's also an end-to-end folder up here, which here is being powered by Cypress, but it could totally be also Playwright. So we're gonna have a look at that later. And there's also some more config files around here, ESLint, that has already been pre-configured. There's some pretty.ignore file, pretty.rc files with some minimal configuration here that can be useful for actually developing in a productive manner. So how do we launch this application? That's the first thing we want to do. Now, first thing you would want to do probably is go to the package.json and inspect what we got there. And we have the usual scripts that you would be familiar with in other setups as well. So we have a start script for running our app, serving it basically for building it and for running our tests. So how do these serve, build, and test commands work here that we pass to Nx? So these are basically targets that we can invoke on our project, and they are defined in the project.json. Now you can see the project.json as almost an advanced package.json script section, which allows us to provide more context and more metadata to the actual commands that we're running. And in fact, you see these target specification here. You see that we have build command here, a build target, serve target. There's a preview target for running the Vite preview server. There's one for testing, for linting, for serving static, basically where we build it and then run a static server on top of it. And you could even provide your own custom targets to define here in this project. So let's quickly have a look what the serve target looks like and what the anatomy of such a target is actually about. So usually every target is defined by such an executor. An executor is a function that runs the task. So it encapsulates what like an npm run script would do. And in this case, you can see this function lives in that Nx Vite package and it invokes the dev server function. And the Nx Vite package is a plugin that we have installed, which you can find here in our dev dependencies. And it's something that gets set up if you choose to use the Nx React plugin to set up your React workspace, which is exactly what we did when you chose the React Standalone project setup. And furthermore, then these executors get options and configurations. And so in this case, for instance, it has a build target option, which tells this dev server that this is the build command it should run in order to serve the application. So if you go a bit up and look at the build command, you can see here a couple of options like the output path, and we can even provide different configurations for development on production mode. So if you want to run this now, we could obviously just go ahead and say npm start or npm run start to invoke that npm start script, and that in turn would invoke the nx serve, or we can directly just say npx nx serve. Now note, I prefix it usually with npx, and this for the simple reason because I didn't have nx installed globally on my machine, but you could totally also install it globally and you could just then run nx directly. So if I run now nx serve, it would obviously underneath use vite to run the development server. And if we then go to localhost 4200, we see our React application being served here. And what you see here is that nx welcome component that we have seen in the initial setup. So similarly to the nx serve command here, we can also run other targets. The syntax is always nx and then the target name, and optionally the project name if it is different from the actual main project that we have in the workspace. So our main project here is the actual source folder level project. That is the one we are developing here. But we have a project also here, which is the end-to-end test project, and we could potentially have more, as we'll see in this tutorial. But if, for instance, we want to run the linting, we can just run nxlint, and this would now run the ESLint on our project, on our application here. And similarly for other tasks. We can also run multiple commands at the same time, and what Nx will try to do then is to parallelize them in the best optimal way, even considering dependencies between those tasks that might potentially exist. And so for that purpose, we can use the run many command here and then pass --target or just -t and then say we want to run the lint, the test, the build, maybe even the end-to-end test automatically in parallel on these projects that exist here in this workspace. There's also the option to filter these projects by providing the -p or -- projects. And so now you can see how Nx in parallel runs these targets on our workspace. The console log output here is nicely structured in the sense that you just see which targets and tasks have been executed while running this command. And only if there was actually an error, you would see the full stack, obviously, for that project that failed. This is especially important if you run multiple of these at the same time. Now, one part here to consider which is important is the caching that kind of plays in. You can already see that since we ran the linting beforehand, this one hasn't actually been run, but it has been pulled out of the local cache that Nx provides. And in fact, if I would rerun all these commands, they would be immediate because there was no point to rerun them because we didn't change relevant information such as the source code or environment variables or other types of input that we provide. And so here you can see the Nx cache in action, which just pulled them out and therefore led to extremely fast response times here. So a question that might come up now is like, how does Nx know which commands are actually cacheable? Because not all of them are potentially. So a cacheable operation is usually one that is idempotent, meaning if you run it multiple times, it doesn't have any side effects. And so, for instance, a test, an end-to-end test that reaches out to a backend, which then queries a database to return some result, and you verify against that result, might have potentially side effects, and so it's not really a reliable one to be cached within a local workspace. And so Nx defines these cacheable operations in the Nx.json. And so that's the second Nx-specific config file, if you want, to the project JSON that we have already seen. So in that Nx.json file, you have a cacheable operations section at the very top, where you also have a runner for Nx Cloud if you opted into that with a specific token as well to be used on Nx Cloud. If you didn't do that, you just have a local task runner, which will store your cache just locally in your node modules folder. But important section here is these different targets that we define that Nx should cache. And you could obviously remove these or add them based on how your workspace looks like. So if you scroll a bit down, you can also see some more configs that might be potentially interesting to explore, which is kind of a bit outside of this tutorial. But you can basically define task dependencies such that like you run tasks in sequence. You can define further inputs to your cache to further fine-tune what needs to be cached. For instance, you just want to include all the TypeScript files, or you want to include some specific Markdown files or exclude spec files in the build. So by now you have seen how we run such targets, such as to serve our application or lint or test it with Nx. And you've seen how we used such a project.json file. You might be actually wondering, why do we need to do that? What is that Nx Vite plugin as we define it? Why don't we just define these in a package.json script here and just trigger directly Vite or Webpack or whatever bundler we're using? And that's actually a legit question. So what we're doing here is leverage Nx plugins because they provide some very nice DX, which we're going to explore in a second. But what does that mean? What is an Nx plugin actually? So if you go to nx.dev/docs, there's a section about why Nx that also includes a high-level architectural overview of what Nx is about and how it is being structured. So you can see at the very bottom here, we have the Nx package, which is a single NPM package that you can use alone. For instance, a combination with your existing quick setup, or you have already a Vite React setup and you just want to add Nx for like improving the task running, for getting capabilities such as caching and distribution of tasks and more of these things that help you speed up your workspace. What Nx then also has, and which you can optionally use, and what we are actually doing in this tutorial here, is these plugins. And these are NPM packages as we have seen here in our own workspace. So we have here plugins for Cypress, for JavaScript, for the linting, the React one, which is the main one we are using, but also the Vite one, which we are using for bundling that React application. And so these are plugins that are usually very technology specific. So they cover the aspect of developing an Angular application or a React application or a JavaScript or Vite application and provide some DX around those technologies. One such feature is the ability to generate or scaffold code for you. And so to understand what features a given plugin provides, you can run the npx nx list and the plugin name. And so in this case, we use nx react. And this will give you a list of here generators that you can use to scaffold out new code. For instance, we can generate an application, a library, which we'll have a look later, but also, for instance, a component. Now, to run such a generator, we use the npx nx generate command, or just G as a shortcut. We give it the name of the plugin, which is nx react : and then component for the generator name that we want to use. We can call this hello world, and then append, for instance, a dry run to just perform a simulation of what would actually happen. So here, for instance, you see this generator provides a couple of questions where it says like, should this component be exported in the project? And we don't want to export it because it's just part of our application. And so then it would simulate what would be happening if we remove that dry run flag. Basically would create such a hello world folder and a CSS file for CSS modules, a spec file, and the actual component in that folder. Now you can see there are various options that we can potentially pass to a generator. And so you can look them up on our docs, or there's even another way for running these generators and exploring them in particular, which is to install NX Console. So to generate a component with NX Console, I can just click the icon here, run generator, and then search, for instance, for component. And you can see we have the exact component generator for that NX React plugin again. And this will open up here a new form. And now I can, in a visual way, provide the various options to this generator. For instance, here I'm saying I want to call this hello world. This is going to be generated into my React application, of course. You can see it simulates the dry run below here. And we could potentially provide further information here, such as the directory we want to generate it into, or even expand all the options, which is a bunch more to further fine-tune how we want to have that component generated. Now in this specific case, I'm just clicking here, generate. You can also copy the command for further use, which is really handy if you need to generate components with different names, for instance, multiple times. So once this runs, you can see here in my source folder, I get a new component, which is here hello world, which I could now just embed into my project and run it. So now we have seen how to serve our application. We've seen how these plugins provide some abilities such as code generation, and we'll see some more of these features in a bit. What is missing to kind of close the circle is how to build our application to actually ship it. And so to build our application, we can use the build target that you might have seen initially when we explored the project.json. So there is already such a build target defined which has some options in here. And so to run this, I can just run it with the same syntax that we have seen so far to run nx build. And this would now create a production bundle using Vite in this specific case and place these files in my dist folder. So if I go here to dist, I can see here there's my React app. There are the assets and the index.html and favor icon that I can now take and deploy to my server environment. Awesome, you made it through the first section of this tutorial. And so by now you should have the very basics of using Nx for developing your React applications. Because you should know how to generate a new app, how to serve the application, how to run various operations such as running tests for it, running linting, even running end-to-end tests. And by also having the build part of it, you know how to get those artifacts that you ultimately need to deploy on your server and ship to your users. We have also seen the project.json file, what that is about, the Nx.json file, which allows you to define cache operations and some more even fine-tuning for the caching and task dependencies. And so at this point, you could actually stop and start developing and explore the rest as it comes up on your own. But if you have time and want to stick around, I would want to show you more that is possible with Nx. And in particular, I would want to show some of the more enhanced capabilities that the Nx React plugin provides us, because we have seen the generating part of it, but there's also the ability to create, for instance, such local libraries to modularize our React codebase, make it more maintainable. There's mechanism for defining boundary rules around these modules that allow us to define what parts of our application can be depending on which other part, and much more. So if that sounds interesting, stick around and let's jump into the second part of the tutorial. So one feature that I'd like to explore in particular is how to modularize our React codebase. Because usually what happens is that as your application grows, you just subdivide your areas, which ideally represent your domain areas or feature areas of your product, into subfolders, either within the app or source folder, or however your structure looks like here. The thing though is that even though that's like a good approach to do, it doesn't really scale well, especially if you have multiple teams then working on it as your application gets bigger. Because it's very easy to just import something out of another folder, which you might not be supposed to do. Let's suppose the product area has a button or some product item which you want to use in your order list, but you're not supposed to do that. You rather are supposed to create your own. So nothing really prevents you from not importing it. And that leads to then very messy interdependencies between these features, which are then hard to separate. So one approach that we kind of promote with Nx is to create local libraries. So let's have a look at what that actually means. I'm going to use Nx console here again, and I'm searching for library. And you can see here we got two different library versions. One is just a plain normal JavaScript or TypeScript library with no specific setup for any framework, which can actually be useful for, let's say, handling authentication logic or just utilities, things that are not really tied to React itself. If you want to develop React components though, like it's better to choose for that React library because it will have already some TypeScript specific setup that is particularly configured for working with React. So let's call our first one products. I can choose here a unit test runner, which I want to use Vite test in this case. I don't need a bundle right now. And for the directory, I could just place all of them at the root of my workspace, so alongside the source folder. But I actually want to group these, what I call modules, in a subfolder. So maybe just let's go with modules here at this point. We can check again the dry run where this would be created. And so you can see here we would get modules, products, and then our actual library would be created inside that. So let's copy here the command because it might be useful for the follow-up modules that we're going to create. And so once this command terminates, you can see here we get a new modules folder and a new products folder in there. And this products folder here actually represents our library. So what does a library look like? You can see here we have an index.ts file, and this is kind of like the public API of that library where you can expose components to be used outside that library. And on the other side, have other components just live within that source lib folder, which should stay within that feature area or library. And so here, for instance, we just have like an example component that is called module products, which just basically exposes this type of logic here. You can also see that each of these has an ESLint setup. It also has testing setup with Vite. So if you scroll here a bit down, you can see here there's a test setup with Vite test because that's what we chose in the original setup part of this library. So we can now even run linting and testing just for this specific library here. And to do so, we can just use the name of this library. So rather than running npx nx lint alone, which would then trigger the linting process of our React application, we can now give it the name of the library, which is called modules product, and then run it. And so this would now run linting for just this single library, because you might just be working on the specific one. So let's create some more of these libraries. So I had copied the command in NX console, so we can reuse it here. In this case, let's call this orders and leave the other settings the same. We don't want to have a bundler in this specific case, similar to the products one. And so again, we would get now an orders library, and we could have potentially a third one, which we call UI. And in this case, we might want to have it in a shared subfolder, because orders and products are very domain specific, while UI might contain general purpose UI components that we can use across all of our other domain areas or modules. And so you can see by nesting this, it would create a shared folder within my modules and then UI. And you could obviously have potentially more, such as some utils folder or authentication, which might also be a cross-cutting feature that we use across these different modules. So now that we have these local libraries, how do we use them in our React application? That is actually pretty straightforward, because what happened during the phase of generating these libraries is that in our tsconfig base, these default mappings have been created to point to these specific libraries. So we see now we have, based on the name of our application here, this prefix /module/orders that points directly to the index.ts file, so that public entry point for that library. And so we can go, for instance, ahead and say, let's go into our product domain here and generate a new component. So I can directly also right click and say generate, and let's call here create a new component that we call product list. And so let's generate direct into that library. So once we have it in here, we can go and export it, because we want to have that actually visible to the outside. And then we can go directly into our React application, let's say here in our app component, and we could go ahead and just import it directly from there. So we can say my React app products, and at this point we would have the product list component at hand here. Now what we could also do is to connect it, for instance, over routing. So let's do exactly that and first install here the React router. So once we have installed it, let's just go here to the main tsx file, and let me just paste in here the setup for the React DOM router. And then we go to our app component, where we actually want to reference our product list and load them in based on the route we are sitting on. So let me also paste this in. And what you see now here is we import here our product list from that products library that we created. And then we define a route that points to /products, which then will load this product list component. So let's serve our application. Let's navigate to the 4200 port. You see here home that is being loaded when we just go to the very root level route. And then if we go to products, we will see how the product list will be loaded in. So similarly, we can do the same for our orders list. So let's go to the modules, to orders. Let's actually just repurpose that orders component that we have in here. So let's call this one here orders list. And we should also rename these here. They are already exported here. So as the next step, we can go directly to our app component, and similar how we import the product list, we just pull in the orders list as well. And then clearly we want to have a new route defined that pulls in our orders list directly into our application. So you can see we get now a much more modular architecture as we keep going here, where we have already separated our orders area and our orders domain and our products domain from each other, and then connected them independently to our React application. Another thing that we can do in Nx is actually to visualize this relationship. So we can run the nx graph command, and that will then serve up here a browser window, which allows us to explore how the structure of our application looks like. So you can see exactly how we have that end-to-end test project. That kind of depends on my React app, because whenever we run and change this, it should also need to run the end-to-end tests here. We then see the connection here to my orders. If we click on here, we see that happens in the app tsx file. And we have still our module shared UI, which we didn't connect to any of our projects. But in a real world scenario, we would have many more of these that would be also connected down here to the products themselves. So we have now nicely modularized our React application into these sub areas, or business domain areas, as we could call them. And this is already a much stronger boundary than we had before if we would just have subfolders in our application. However, there might still be more constraints that we want to impose here, Because for instance, we might want to say that the UI component library, which is more of a general purpose component library, should not be able to import things out of the products library, which it can totally do because the product library here exposes certain components from that index public file here, that index.ts file. Similarly, we might also want to say that orders can only pull in components from products, but not vice versa. And this is exactly where the Nx boundary rules come into place, which is implemented as lint rules. Now, how you define them really depends on your system, and all that Nx provides you there is a mechanism to implement different variety of rules. So at the higher level concept, what we have seen to work out very well is to define two different dimensions. So first of all, you want to define which type of projects can depend on which other type of projects. And this could be like projects of type feature, which is like order and products, and projects of type UI or type util, which can be here our UI library or utility library. And the second dimension can be the actual scope. So there we have here a scope orders, we have a scope products, we have a scope shared, which you can assign to these projects. And then you can define rules where a scope shared can only import from other scope shared, while a scope products, for instance, scope order can actually import from a scope shared. So let's see how we can define these. To impose such constraints, first of all, we need to tag these projects in a way that we can associate them to a certain category. So here, for instance, we could say this is of scope orders and of type feature. And similarly, we can go and assign a similar tag here, where we here say this is scope products and type feature, while in our shared project down here, we say this is of type UI and scope shared. Now, these are just arbitrary strings. You don't even have to use a colon here. You can define them however you want. This is just for us a separation to distinguish between the category and the actual value of that category. So once you have defined these, we can go to the root level ESLint file here, where we have the Nx enforced module boundary rules already defined. And now we can add here further constraints. For instance, we can go ahead and say the source tag type feature can only depend on libraries that also have the tag type feature, but also type UI, because we won't definitely be able to pull in components from our shared UI components. And in a similar fashion, we can now say our type UI components or type UI libraries can only import from other type UI. And potentially, if we could also have here type utils for some lower level utility libraries. And so this gives us the first dimension that defines from a type to another type. We can then add in the second dimension, which says here from source tag scope orders, we want to be able to only depend on scope orders, scope shared, and we might even say we want to be able to depend on scope products. So an orders library can import features and components from the scope products. And similarly, we can define here the scope products that can only import from other scope products if we would have multiple one, and the scope shared. And the very leaf node here would be then the scope shared, which can only import from other scope shared. And so with this, now we have these two dimensions defined in our rule system here at the ESLint base JSON. And now we can test it out. So potentially we could now go to our products domain and try to work against this rule by going to our product list and trying to import here the orders list. And you can already see if we do that, we will get a linting error directly in our IDE saying that a project tagged with scope products can only depend on libraries tagged with scope products or scope shared. So you can already see how this violates the rule that we have implemented. And in a similar fashion, if we are on CI, obviously we would run the lint on the command line. So let's say we use the run many here and run the linting process on all our projects that we have in here. We will get a linting error here saying the exact same thing, that projects tagged with scope products can only depend on scope products and scope shared. All right, that's it. You made it through the entire tutorial. Congrats. So you now should have actually a very deep understanding of how Nx works, all the various mechanisms that we have seen of modularizing a React application, but then also imposing some constraints that help with maintainability, and also how to leverage those features that the Nx React plugin provides. So now next steps could be looking at some of the other plugins, such as how to add Tailwind support to your React application, or add the Nx Storybook plugin integration to build out our shared UI component library and how Storybook could help with that. But also how to set up your CI in the most efficient way. So the next step could be looking into how caching works, how you can set up a CI system that is efficient to only run, for instance, tests or linting against the projects that we touched in the specific PR, and much more of those things. Or you could also look into how you can potentially evolve such a workspace to a monorepo workspace if at some point you have a second React application, a Remix or Next application, and you want to have them in the same workspace. Also, make sure to subscribe to our YouTube channel, like the video, let us know in the comments what you think about the tutorial, what you would want to see us explore next, and hopefully I see you on some of our next videos.